So question 11, define the term molecule. Okay, so we did this as a major part of this lesson. So the molecule is the smallest particles of an element or compound which can move independently of each other. Okay, so that's a fairly straightforward answer from all the stuff that we've done in the previous lesson. The question then becomes, why can noble gas atoms be considered molecules? Well, using the definition that a molecule is the smallest particle of a substance that contains the chemical and physical properties of that substance, atoms of noble gases contain all the same properties of the noble gas. Therefore, they can be considered a molecule based on that definition. So most of these things are just definition, and the only reason why we can argue this way is because we define them that way. Okay, so a lot of science is about making definitions, and often these definitions are very arbitrary. For instance, why is the electron negative and the proton positive? Why is it not the other way around? There's no real reason. It's just that's the way it is. That's the way they've defined it. So you can see that we define things simply to understand them and to understand the relationship between other things. So we got this one charged object and this other charged object, and they're very, very differently charged. So how do we define them then? We just say one's positive, one's negative, and there we go. So you can see that definitions in science are sometimes very arbitrary, but they're important simply because we need to use them to define relationships between other substances. So, can the chemical CO3 2-, which is the carbonate ion, be considered a molecule? And the fact that I called it an ion kind of implies that it's not a molecule, but the question then becomes why? No, molecules in general are electrically neutral. So therefore, this carbonate ion is not a molecule as it's charged. If you allow molecules to be not electrically neutral, so they could be charged, then it becomes a nightmare trying to figure out what's an ion and what's a molecule. So by completely eliminating anything that's charged, it allows us to make better differentiation between what is an ion and what is a molecule. So for instance, if you allow molecules to be charged, you get a situation where something like this, CO3, 2-, well, it's got lots of covalently bonded things inside it, but it's charged. So do we call it an ion or do we call it a molecule? So you see there's ambiguity involved. So it's better to just say everything electrically neutral and then everything charged as two separate things. Otherwise, defining things, again, it's what we're focusing on here. Defining things becomes a nightmare. So how do molecules interact with one another? Well, molecules interact by colliding with one another. They only interact through collisions. So since each of the molecules moves independently, collisions cause changes in momentum and direction. So if you imagine two billiard balls coming towards each other, even though in billiards one's always stationary, but let's just ignore that for a sec. So you imagine they hit each other, then they're basically just bounce off one another and go in weird directions, right? And you can sort of explain the collisions using physics, but we're not going to go into why. So you can see that when they collide, they change their direction and their momentum. And that's the only way molecules can interact with one another. They're not like, Superman or something, or, they can't just, interact with things with their minds because they don't have brains. So they just interact basically by colliding with one another. They don't have any other way of interacting. Question 15, distinguish between an atom of hydrogen and a molecule of hydrogen. Okay, so we've got an atom of hydrogen and a molecule of hydrogen. So what's the difference? So an atom of hydrogen is the smallest unit of hydrogen that can take part in a chemical reaction. So a hydrogen atom can take part in a chemical reaction. A hydrogen molecule can take part in a chemical reaction. Okay, so both of them can react. However, one atom of hydrogen cannot exist and move independently by itself. Okay, so it can't actually. By itself kind of implies independently. One atom of hydrogen can't exist by itself, so it can't move either. So there's one difference there. The smallest particle that can do this is a molecule of hydrogen, which consists of two atoms. That's why a hydrogen molecule, even though that's the elemental state that it's in, that's the state that we find it in, that's how it exists, because it can move independently and it can actually exist by itself. Whereas an atom of hydrogen can't exist alone and it won't be able to move. So we don't use that as our definition of the hydrogen element. So that concludes today's lesson on molecules. We looked at the definition. We looked at basically molecules, but in a broader sense, we looked at why scientific definitions are the way they are. Okay, we looked at trying to understand the reasoning behind why we make certain definitions and why we allow them to propagate even though they don't really feel intuitive. Whether we've covered a lot of chemistry here, probably not, but in terms of what we've learned about science, we've covered a great deal, because definitions in science are one of the founding pillars of things that we need to understand in order to understand fully the concept of science in society.